Hi everybody, so welcome to week 7. So today we talk about the SQL DML. So in this module we learn about the SQL DML. So this is the content of the slide. Basically we talk about the two things. The first thing we talk about the how to do querying single table. Second part we talk about the how to do querying in for multiple table. So in the first part, we also need to do the how to find the information, subset of tuples, what is predicate. We also learn about the all column, projection, alias, and concatenation. We also learn about the how to do the sorting result, nulls, aggregate function, union, grouping, recession, and aggregates. For the second part, we learn about the joining. So this first part. When you add information to a database, you chop it up into smaller pieces whose meaning and structure and their relationships are exactly defined. When you want to find some information in these pieces of data, you run a query. SQL has been invented as a powerful tool that can combine pieces of information in a large number of ways. Query, I will start with the keyword select. So select query retrieve data from one or more table. Therefore, you have to specify at least one table that has the required data. The from keyword identify the tables. Therefore, the from keyword is never missing in a valid query. Before the from keyword, you can see a number of column names. The select statement specify the attribute to include. They are also mandatory. Picking the attribute is called a projection. Now we have projected 3 of the attribute of the product table into our result set. The result of a query in SQL is often called a result set because of the roots of SQL in relational algebra. This is actually slightly misleading because sets don't have duplicates but SQL results do. You can see the projection create a type of vertical split of the original table. Some column has been left out. In this case, the ID column, but you have not imposed any horizontal split. The result has just as many rows as the original table. This is not always desirable. Table can have lots of entries, and chances are you only interested in a few of them. If you want to find only a subset of the row in the table, you simply add a where clauses to your select statement. Where clauses impose conditions that restrict the number of tuples included in the result. Therefore, they are also known as restriction. To add more terminology, where clauses are also called predicates. If you use string value in your predicate, you have to place the literal value in single quotes. The string is case sensitive. There are a number of comparison operators you can use in where clause. Where clauses can naturally use less than and greater than comparison. If you combine the two symbols, it means not equal to, but the not equal symbol can be different depending on the database. MS SQL Server use Java style not equal. DB2 use yet another symbol. If you want to use wildcard, you have to use the like expression. A percent sign means any number of digits of character, and underscore means exactly one character or digit. Between and can be used for numbers and dates. It includes the extreme value. So In this case, value from the 1st and 31st October are included. The in expression lets you enumerate several options for the matches. At this stage, you may wonder whether you can use regular expression to search database. Naturally, you can, but the operator is different in each database product. Just do a web search for regular expression and the database you are using. You can use the and or operators to combine restriction in predicates. You can also use parentheses if you need to make more complex option. If you need to check for null value, you have to use is null or is not null. The equal comparator does not work in this case. Traditionally, all SQL keywords were capitalized, which made the statement easier to read. This day, DBS will accept SQL query where the keywords are not capitalized. Select star or asterisk is the shorthand notation if you want to include all attributes in a projection. It's a good place to start writing your queries. First, you refine all your predicates and other details. When the query does what you want, you can decide which column are actually needed. You can then you decide which column you actually need. You can concentrate string using a double pipe sign. If one of the value that is being concatenated is not a character field, you have to use a COS function first. In the example, category and name are both character fields. We want to put them into the same column in the result set. And separate them by a dash. The dash and two spaces on either side are literal string. The literal string is printed in single quotes like all characters value. So the categories value goes first, then a dash and then the name field. The S keyword indicates we are renaming the column. The column is the result of computation, so it does not actually have a name. But if you don't mention a name, the database will make one up. The column heading when auto-generated will look different in different databases. It is better to decide ourselves when the column heading should be. As description means we want the column heading to be description. We can use aliases for any column in a result set. It does not have to be generated one. In the example, we name location to chef. Can you imagine what the result looks like? Pause for a moment if you want to think about it. You can sort the result set by any column. You can have any number of columns in your order by clause. This means that the sort happens on the first column, and if the first column has duplicates, these duplicates are sorted by second column, etc. Clearly, if your column has unique value, there is no point in using secondary column for your sort operation like in this case. The more column you use, the more unique combination you have. So everything beyond 3 columns is usually unnecessary. So operations are expensive. So think about what you are doing before you include such SQL in an application. We have already discussed null value in a previous module. You know that you should avoid having null value column whenever you can, because null can cause trouble. Things we don't know about are hard to query. Now you see how null affect query and how to deal with it. Suppose we are querying the customer table by gender. We want to find all the female. There is one null in the table, and the person appears to be female based on the first time, but there is no way we can pick the entry up using a gender query. That's probably what you expected, right? So no problem then. What if you want to fetch all customers that are not female? We can apply the negative equal symbol and expect to get 3 rows that are not female. Now here is the catch. If value is null, we cannot say that is not female. The value is unknown. So there is a chance it might be female. There is also a chance it might be male. We simply don't know. The problem is that people tend to forget this and expect null to be included in this case. If you really want to pick up the nulls and the male tuple here, you need to check for null explicitly. All database products implement the aggregate function sum, average, count, mean, and max, which are been seen in the relational algebra. There are several more. For example, the ABS function that returns the absolute value of a number. You can use the count function to count all the rows in a table. You can also use count on an individual column, such as the ID, to get the same result. But you have to be careful. If the column is nullable, the nullable value may not be counted. If you use sum, average, mean, or max, you can use the star because you have to say which value need to be total. You can sum up different column in the table. So all other aggregate function need a specific column in the parentheses behind them. Aggregate functions are clearly useful, but having to apply them to the entire table is very restrictive. Suppose you want to know how many products you have in each category. So this could be very tiresome task. You have to query the database for all different category entry, then apply each of them in restriction to find out the count of product in each category. Naturally, SQL has better solution for this. But first, take a look at the category projection in select statement. Move is literal value, so it is not fetched from database at all. It is given an alias of category, and you can see it appears in the result set as a column of its own. Making up new column in the query on the fly is sometimes helpful. In the case, there is a chance that you need to do this because your database product may not be happy to let you simply include the category column from the database. Why do you think that might be? Well, if you think of it, the count function could include a number of columns if there are several long vowels, unless you know that the decision is on the same column that you include. So you could not be sure the category will be the same for all this row. Which value should be shown? If the database is clever enough to figure out that the category is the same field as the restriction, and the value has to be the same, it will be happy for you just to include the category field if you want to show in it your result. As it happened, MSQL is that clever. Now suppose you want to have result for all categories in the same table. So what we could do is union. Union unites several results in the same result set. Obviously, this only makes sense when each category returns a result that can be placed in the same column in the result. So, from that perspective, the example is perfect for demonstrating how union works. First, we have added a few items to the products table to get slightly more interesting result. Now we can look at the query using unions. If you write a query that returns a count for each row that has a particular category, we can put them in the same query by putting union between them. As long as we use the same column for each result, the query will run in all database products and give us a result for each query combined in one result set. This is cool if you want to show how union works, but rather silly as a solution for the task of finding the number of products by category. The way we should really be solving this problem is by using the group by clause. If you use group by, the aggregate function you use is applied to the groups rather than the entire table. So you can get the count of the product per category without having to mention the individual categories. You can also group by several columns if you want to count the number of electric tools that are found in the same location. For example, with grouping, the rules is the every column you use in the projection also have to be mentioned in the group by clause. This is often a case when newbies does not get the grouping statement to work. If you look at it from the logical angle, most group form in the grouping statement have more than one row. So suppose you wanted to include the name of the product in the result set. Naturally, this won't work because for each category, there will be several names. Choosing any one of them will not make sense because unlike the category, it does not describe the count attribute. So unlike you have two columns in the group by statement, you cannot include in its listing. So if you need a restriction that use aggregates, the where clause does not work. You'll have to use having instead. Where clauses are static predicates that can only work on existing column. If you do a count, you create a new value that does not exist in the database. Aggregate function have to do a grouping while they calculate the result. Therefore, the grouping have to exist before the value can be returned. Where cannot work on groups. Therefore, we need the having clause here. So this is the most important point discussed in this model. You may want to stop the recording to have a read through them when you already start the quiz about this model. You can answer the question in the Canvas discussion. So this is the querying multiple tables. So this is the second part of this slide. You have seen these three tables before, right? So there are two strong entity, which is student and subject, and a weak entity between them. You may still be grappling with the concept of weak entities. If this in this case, think about where you could place the mark column if the enrollment does not exist. If it was in the student table, we will need as many duplicates for the student as she had enrollments. Not every practical. If the mark was in subject table, we will need as many duplicates for each subject as there are students. This is why we need another table that holds all the properties of the combination of student and subject, which is naturally enrollment. Most of the time, our database have one-to-many relationship, as we do here. When we combine all rows from two tables with one-to-many relationship, how many rows do we get? Naturally, as many as we have child row, the child table is the one on the many end. The column from the parent table just have loss of duplicates value. You might guess that looking at the foreign key column, because the foreign key column dictates what the entry in the parent table columns are. Other thing is the table often has attribute with the same name. You have been told that it's good practice to prefix an attribute with the table's name. In many legacy databases, these rules have not been observed. So you will have to deal with situation where different databases have attribute with the same name. In the example, both subject and student have a name column, so we can see how to deal with the issue. When we want to combine information from several databases, we talk about joining tables. Although what we must do is joining a subset of the tuples in the table by a join column. Suppose we want to have listing of student and year mark for the subject they look in 2016. We need to project the student name, the subject, semester, and mark. To get this from the two tables, we have to include both tables in the from clause of the statement. The result is what we expect. Initially, The row in the result set are based on the row in the enrollment table. The student ID has been replaced by student name, which is more informative. There are several variations of syntax we can use to join the table. Join and using is one of them. Using works when you have column that has the same name in both tables. The order of the table makes no difference. You could write from student join enrollment. Another version of syntax is natural join. Many people think that a natural join is the same as joining tables by foreign key. This is not the case. Natural join uses the column with the common names. This is important to remember. If you could join student and subject, natural join will use name, and you will be terribly surprised not to get a single result. If you don't have identical column names for the join column, this is what you do. Join condition using onLet, you specify a relationship between the columns. By far, the most common is echo join, where there is an equal sign between the columns. In the theory, you could have other operators such as less than and greater than. In this case, using on structure is overkill because the column actually have the same name. This adds another complication. If you say on student ID, the database will complain that your columns are ambiguous. But there is a way out. You can give each table an alias that make the clause shorter. Now the clause names are not ambiguous and the clause is reasonably short. Before SQL92 standard was certified, the join keyword did not exist. All tables just listed in the from clauses, separated by commas. There is no special keyword for specify the join column. So this just added to where clause, which can make the where clause very long and difficult to read. This is why this notation is encouraged. But you cannot always avoid it. Some database products have never caught with the join statement. Oracle, for example, need this all-star join syntax. Having said that, even their all-star join notation lets you use alias for tables. Now, we have mastered all possible notation for joins. We can have a look at including several tables in the join. For example, the subject ID in the subject is not very easy to read. Meanwhile, we might want to add the subject name to make it easier for people to interpret the result. When we do this, the alias come in very handy because now that we include the two tables that both have identical column. Even including the column only once will cause problem because the database system cannot figure out which name field we mean. So we will receive an error unless we prefix it with the table name or the alias which is shorter. This example shows the syntax if we need to state the column joins explicitly. Since we have conveniently named column, we can actually shorten this considerably by using natural joins. There are inner and outer joins. What we have just seen were inner joins. The inner keyword need not be used. Joins are automatically inner joins when you specify nothing. Outer joins are all about what happens when rows don't have mesh in other table. With left and right outer join, it matters which table is mentioned first. Because with left outer join, we only include unmeshed rows when they are in the table that mentioned first. If you say neither left or right, the default is full, meaning both tables have their unmatched row included. Let's look at a more interesting example where we average student grade so far. Unlike in the previous query, we won't put an restriction on the year. We want the average performance to that. Using the aggregate function average, we have to do a grouping. Since we want to have the performance per student, we group by the students. We notice that none of the column in the enrollment tables is included. This makes sense because we want the student performance overall, so we cannot specify semester or years. We could, however, include the student ID, but if we did, we will have to include it in the group by clause as well. So, database system don't take kindly to including columns that are neither aggregates nor mentioned in the group by clause. Having said that, in the current query are relying on fact the names are unique, well, in practice they are not. If you had two Peters and two Han among your students, all they must get mixed up. For this to work, we are assuming that the names are unique. Now we have a nice listing of all student names and average marks. But you have noticed Anna is missing. Because Anna has no enrollment entries, this tuple in the student name has no matches in the enrollment tables. This is why an inner join will not pick it up. If you supply a right join, it has to be outer because of the right keyword, so the outer keyword is optional. Anna is included. The value for average is in MySQL is 0. This entry arbitrary choice, not heavy entry for the mark column in enrollment is tantamount to having null entry. There are no entries, so mark is a noun. You have find some database product will opt for null, some for 0 in such case. Not we need to right join here because the student table is on the right hand side. A left join will include rows without matches from enrollment. But we have implemented enrollment properly. There will be no enrollment without students, so left join will have the same effect as inner join. Anna will be missing. Similarly, if you set outer join or full outer join, the results look the same as it does here because the additional row will be included, but there will be no additional row from the enrollment table. In the first join query we look at, we had a restriction on the year, and Anna was missing because we had an inner join and Anna has no enrollments. But in this case, changing to an outer join won't include Anna because even when we include student without enrollments, the restriction on the year means that Anna will not be included. Why is this? When a student has no enrollment but we include the student anyway using an outer join, all the field from the table that has no entry for this student will be null. Hopefully you remember that null value never evaluate the true value of false. So really we cannot tell whether Anna non-existent enrollment has year of 2016. Therefore, you have to add or clause or year is null to make Anna appear in the result. This is just in case you wonder. If you cannot get your head around this, it doesn't matter. It will all become clear when you use SQL professionally. View are simply stored query. One of the advantages is stored query are pre-optimized and execute faster. Another is that you can regulate access to that using view. You can prohibit a user access to the base table and give him access to a view instead. View can omit attribute as well as tuple, so you can limit access both horizontally and vertically. Amazingly, view can actually be edited if they are constructed in a certain way. The result of an update, a view makers make changes to the table involved in a view. Another advantage is that view make query easier. Many queries can get very complex and when users struggle to understand them. Mistakes are made. Query in view means the select statement that query that view can be simpler than the statement needed to get same information from the table. The example demonstrates this. First, we need view student enrollment. It joins the student enrollment tables to include the student name. So, when we investigate a student performance per year, we no longer have to include the join in the query. This should not give you the impression that you cannot use aggregate in views. You can initially. Essentially, anything that was a select statement with few exception can also be created as a view. So this is the summary. Basically, join ideally used as a join keyword. So we can use between join using natural join or join on. If you have database that doesn't do join, you have to list the table after from and include the join column where in the where clause. By default, join are inner joins, exclude row from either table that have no matches in the other. If you need to include unmatched row, you have to use an outer join, a full outer join, or a left or right outer join. So this is open question. Basically, by given this XML file, please using xquery with flower display the name any test with a CMD or GUI. Type an input of 1. So I will publish this thing in the canvas. So I hope you can participate in the canvas since currently our university management measure student participant in the canvas. So I hope you can take this chance by answer this question in canvas discussion. So I think that's all for this lecture session. I hope you enjoy it, and thank you.